This is Trent Schindler from NASA's Scientific Visualization Studio. Ozone in the upper part of the atmosphere, the stratosphere, is a good thing. It absorbs ultraviolet radiation from the sun, which can cause skin cancer. But in the lower part of the atmosphere, the troposphere, ozone is a pollutant that can create respiratory problems. So monitoring tropospheric ozone is important for mitigating its effects. But sometimes, natural ozone from the stratosphere can make its way to the troposphere, confusing monitoring efforts. One of these events is what I'm visualizing here. In April 2012, an area of fast-moving low pressure caused ozone-rich stratospheric air to descend, folding into tropospheric air near the ground. Winds pushed it in all directions, bringing stratospheric ozone to the ground in the southwest. You can see this as a curtain of swirling air reaching to the ground in this visualization. The air is color-coded by altitude, blue at 10 kilometers and red at sea level. Atmospheric scientists at NASA's Goddard Space Flight Center in Greenbelt, Maryland, set out to see if the GEOS 5 chemistry climate model could replicate the intrusion at 25-kilometer resolution. Indeed, the model could replicate small-scale features, including finger-like filaments within the apron of air that descended over Colorado. To communicate the implications of this result most effectively to non-scientists, we created a volumetric visualization that replaced numerical data with animation. By making visible events that would otherwise have remained invisible to those without expertise and training, the animation allows policymakers and the public to immediately comprehend the nature of the problem and hopefully make more informed decisions in addressing it.